Hey there. So today we're going to look at right triangle trigonometry. This is the trigonometry you're probably familiar with. It's the whole SOHCAHTOA thing, but there is some new stuff involved. Now, when we think of SOHCAHTOA, you're probably remembering this right here. The sine is opposite over hypotenuse. That's the SOH, SOHCAHTOA. So we know these. These might be new to us, though. Recall that all three of those trig functions, sine, cosine, and tangent, have reciprocal trig functions, and they are called cosecant. Cosecant is just the reciprocal of sine. Since sine is opposite over hypotenuse, the cosecant is hypotenuse over opposite. Sometimes it's more efficient to use the reciprocal function rather than the regular sine function, and so that's why that is there. So you have cosine, its reciprocal is secant. You can see that its ratio is flipped. And tangent has a reciprocal function, cotangent, and its reciprocal is, it's a reciprocal of the tangent. If you have trouble trying to remember which ones group with which ones, well, I feel like these two should be pretty easy. Tangent, and then this is COT for cotangent. Tangent and cotangent are going to go together. All right, then this is secant, this is cosecant. So there's these two secants. I guess how I always remember it is with each pair, there's got to be one of the terms that has a co on it. So here's my tangent with my cotangent. Cosine already has a co, so it matches with secant. And sine doesn't have a co, so it needs to go with cosecant. It's silly, I know. It's just my little trick in my head. Now what we're going to do is we're going to take a right triangle and we're going to do some SOHCAHTOA with it, but we're going to do more than the sine, cosine, tangent. We're also going to do those reciprocal functions. To be able to do SOHCAHTOA, you're going to need, here's my theta angle, so I can see that I have the opposite, it's 2. I can see I have the hypotenuse, it's 4, but they didn't give me the adjacent measurement, and I know I'm going to need the adjacent measurement when I do cosine and tangent. So the first thing I'm going to do is go do Pythagorean theorem to find out that third side. So it looks like we're going to have a 2 squared plus an x squared, that's the other leg, is going to equal 4 squared. So that's going to be a 16 minus 4, so that's a 12, square root of 12, so that would break down to 2 root 3. So that's what this adjacent side is, 2 root 3. So now let's go over here and let's find these trig functions since we now have all sides of the triangle. When you're doing sine from theta, you need the opposite side, so that's a 2, and the hypotenuse, that's a 4. So that's 2 over 4, that reduces to 1/2. And then as soon as you know what the sine is, you can immediately do the cosecant. I don't even need to go back to that previous slide and figure out what over what. It's just the reciprocal of sine, so it's 2 over 1, or just 2. All right, let's see if we can set up cosine. Cosine of an angle is always the adjacent over the hypotenuse. So I've got 2 root 3 over 4. And then I would always want to reduce, so that 2/4 can reduce. I'm going to end up with a root 3 over 2 for the cosine. And if the cosine is root 3 over 2, the secant has to be the reciprocal of it. So I'm going to do 2 over root 3. But I do have to rationalize that. So I have 2 root 3 over 3. Let's try one more. Let's do the tangent. Tangent of an angle is opposite over adjacent. So 2 over 2 root 3. Couple things we can do here. First thing I can do is change this to just a 1 over root 3. And then I'm going to have to rationalize it. So now I have a root 3 over 3 is the tangent value. The cotangent is the reciprocal of that. Now, I would rather not do the reciprocal of this version because I'm going to get stuck having to re-rationalize the denominator. Couldn't we go back to this stage right here and just do the reciprocal of that one. So the cotangent is a root 3. Now, I'm not sure if you noticed this or not, but this should have kind of jumped out at you. All these numbers should be ringing a bell off of, well, not these, but these. 1/2, root 3 over 2, root 3 over 3. Those are all straight off our unit circle. And if you look at your triangle, this short side is a 2, while the hypotenuse is a 4. And then the long leg is a 2 root 3. That's a 30, 60, 90 triangle right there. So this is my smaller angle. That's going to have to be a 30-degree angle. Now, that was a total coincidence, but I just wondering if you noticed. All right, so let's practice that a little bit. So I've got 3 different triangles here. In this first triangle, called it triangle ABC, and I'm looking for the cosine of B. So that means I'm looking from this angle here, and I'll write it up here in case it just isn't stuck in your head yet. So COTA. So during cosine, I need adjacent, I need hypotenuse. The adjacent side to the angle B is a 5, and the hypotenuse is a 13. Okay, let's try cosecant of A. Now we're switching what angle we're using. We're not using angle B anymore. We are now using angle A. And we look at cosecant. It matches with sine. Sine is opposite over hypotenuse. So that means cosecant is hypotenuse over opposite. Now from angle A, hypotenuse is 13, opposite is 5. So that just means it's 13 over 5. Now I got lucky there that I didn't have to find that missing side. I kind of waited to see if I needed it rather than just jumping right in and finding it. Now let's look at this next triangle. I do think I'm going to end up using the Pythagorean theorem because I do not know the hypotenuse, and I know that sine requires the hypotenuse. So here we go. 3 squared plus 8 squared equals c squared. So that's 9 plus 64. And I was going to have my calculator out ready to go. All right, 9 and 64, that's a 73. I can do that in my head. All right, so c then is going to be the square root of 73. That does not break down. So, oops, I'm going to put it right here. Square root of 73. Now, when I'm doing sine, I want opposite over hypotenuse. So opposite of theta is straight across. That's 3 over the hypotenuse, which is square root of 73. Let's try secant. Now, secant doesn't have a co, so it's going to go with cosine. Cosine is adjacent over hypotenuse, so I'm looking to do hypotenuse over adjacent. So from theta, here's hypotenuse, here's adjacent. So I'm going to have a square root of 73 over 8. Getting really lucky here. Actually, I wanted to go back to this sine. I kind of walked away from that, but we do need to rationalize that. That's a square root of 73, square root of 73. Your final answer on this one should be 3 square root of 73 over 73. You do have to rationalize. Okay, here we go. Last one. I'm doing tangent, I'm doing cotangent. So that's going to be opposite and adjacent I'm dealing with, which works out pretty good because I don't know the hypotenuse. Looks like I don't have to go find it because I don't need it. So tangent of F. So from F, I need opposite over adjacent. So 24 over 10. But we, of course, can reduce that because 2 goes into both. And so we end up with 12 over 5. Now I'm going to change it. I'm going to go to cotangent of G. So now I'm here. Cotangent is the reciprocal, so instead of opposite over adjacent, I'm doing adjacent over opposite from angle G. Adjacent over opposite. That's 24 over 10. All right, that is not a coincidence. That actually happens all the time. That is a thing where reciprocal functions of the other acute angle in the right triangle, those are always going to be equal to each other. I know that we have a loaded unit circle. We have all kinds of info on that. We're going to look at these new 3 trig functions on the unit circle. This is not something that you have to know. We're not going to add it in. We just should be able to get to it based on what we already know from our unit circle. So on this first one, we've got the cosecant of 45 degrees. Now, I don't know what cosecant is, but I do know that cosecant is the reciprocal of sine. So if the sine of a 45 is root 2 over 2, then that means cosecant is 2 over root 2. Just got to flip it. We do need to rationalize. If you can rationalize in your head, that's going to be awesome. It's going to save you some work for sure. And so I have that. Those cancel. Final answer, square root of 2. All right, let's try to the right here. It's cotangent of pi over 4. Well, pi over 4 is the same as that 45. So the tangent, I'm going to do what I know. I'm going to do tangent at pi over 4 is just 1. So cotangent is the reciprocal of 1, which is just 1. All right, let's jump to this next one. Cosecant of 4 pi over 3. All right, we just did a cosecant up here. Remember that cosecant is the reciprocal of sine. 4 pi over 3, if you'll recall, is down here, and you're down the long leg. So the sine value would be a negative root 3 over 2. But we want the reciprocal of that, so this is going to be negative 2 over root 3. We'll go ahead and rationalize. Final answer, negative 2 root 3 over 3. Let's try again. Secant of 11 pi over 6. 11 pi over 6, if you will recall, is just before you make it all the way around. Now, secant goes along with cosine. And the cosine here is how far over you're going. And so I'm going the long leg. That's root 3 over 2. So then I want the reciprocal. I want 2 over root 3. Then, of course, I'm going to get to rationalize. And I get 2 root 3 over 3. Now, we've done a couple of those now. Not that you're expected to remember it, but you will start to see the same numbers over and over. The reciprocal of a root 3 over 2 will always get you this. The reciprocal of root 2 over 2 ends up being a root 2. Reciprocal of 1, just 1. Okay, so at this point, I'd like you to pause the video and do those last 2 on your own. When you have those done, come back and turn the video back on. All right, these are the 2 answers I got. In the first one here, cosine was negative 1/2, so I got negative 2 as its reciprocal. Second one, tangent is 0 at 180. The reciprocal of 0, that's going to take that 0 and bump it to the denominator, and it's going to be undefined. Now, I'm sure that some of you have kind of caught on to the signs as you're working in each quadrant but I thought I'd go ahead and make a little chart and clarify here. When you're dealing with cosine, you're looking at the x's. So you have to pay attention to what quadrant you're in. When you're in quadrant 1, your x's would be to the right, so they would be positive. Same deal in quadrant 4, your x's are to the right. So cosine is going to be positive in 1 and 4. It's going to be negative because you're going left in 2 and 3. So positive in 1 and 4, negative in 2 and 3. When we look at sine, that's going to be our y value. So you sort of use this x-axis as your boundary. Anything above it, your sine value will be positive. Anything below it, your sine value will be negative. So it is going to be positive in the first and second quadrants, negative in the third and fourth. Okay, last one, tangent. Have you caught on to this one? Remember, tangent is just the sine over the cosine. So if you can just look at these 2 signs, and that'll determine what you're doing. Because I would be putting a positive over a positive. That's just positive. Positive over negative is going to be negative. Negative over a negative is a positive, and a positive over a negative is a negative. All right, next question here is asking you about an interval. This is not like domain, it's not an ordered pair or anything. This is actually an interval. So in the interval from 0 to pi over 3, which I know right here is this angle right here. In that angle, your sine value will be, all right, remember your sine is how far up or down you're going. And on all of this, you're going straight up. So the sine value will be positive. Okay, so let's get rid of that. And then I'm just going to wipe the whole board, I think. Oh, maybe not. Maybe just this. Okay, so in the interval from 0 to 3 pi over 4. So I'm going from here to here. In that interval, the cosine will be you should have wondered like, it actually is both. That was a trick question. Cosine is going to be positive right here, but in this section, it's going to be negative. Now, on our calculators, we don't really have a way, we don't have a button for cosecant or secant or cotangent. Those reciprocal identities do not have a spot on our calculators. So we have to kind of manipulate them a little bit. So let's look at how to do this. Now, one of the things, the first couple here are just sine and cosine. Now, I'm sure that you've done that before, but what you have to have an awareness of is that you are in the proper mode. I want you to find the sine of 47, but that's 47 degrees. If it were 47 radians, it'd be a totally different answer. So you have to be very familiar with switching your mode and checking and making sure that it is in the appropriate mode. Do you want to be in degrees or radians? So check it right now. Mode, we want to be in degrees. When you clear your RAM, it goes to radians. So keep that in mind when we clear our RAM before a test or something. At that point, it'd be in radians, which is sometimes good, but sometimes you need degrees. Okay, so on this problem, when you hit sine of 47, you should get, and we typically round this to the hundredths place, so I'm going to go 0.731. I said hundredths, I meant thousandths place. Okay, next one. Oh, now this is an example of where you'd want to be in radian mode. So then you'd hit mode, switch it to radians, and then you're going to type in cosine. It automatically will open a parenthesis, and then you do 4 pi divided by 3. And you should get a negative 0.5. That one actually comes out nice. You can add the zeros if you want, don't really have to. Okay, let's try this next one. Now we're getting into something. This is the cosecant of 3 pi over 7. First thing is that I'm in the appropriate mode. I was in radians. I still want to be in radians, but I have to do cosecant. Since there is not a cosecant button, what I'm instead going to do is I'm going to find the sine, which is its reciprocal, of 3 pi over 7. So let's do that. Let's hit sine, and then do 3, and then get your pi, second caret, and then hit divide by 7. Don't close your parenthesis in there or that will mess it up. Now you can close it at the end, but it does default to close. So then you can just press enter. Now what you should be looking at is a 0.975. But what we want is the reciprocal of that. We actually have a reciprocal button to make it easy. It's this x to the negative 1 right here. If you just hit that button right now, it'll say, take your answer and do the reciprocal, and then press enter. And ideally, you are looking at a 1.026. All right, so at this point, then I'd like you to go ahead and pause the video and go do those other 3 on your own. Okay, never mind. That might be a little quick because I only did one of the weird ones. Okay, let's try it again. Let's do one more. Secant of 12. Now, is 12 in radians or is that in degrees? If it doesn't have the circle, it is in radians. So my calculator's already in radians. So I'm going to go to the secant. So that means I got to do the cosine. So I'm going to hit cosine 12, press enter. And now you want to do the reciprocal of that. So we hit our reciprocal button, the x to the -1, and then press enter. All right, I should have commented, originally I had a 0.844, but when I did the reciprocal, then I get a 1.185 on that one. All right, so let's try this next one. I'm just going to finish them out with you. Secant of 120. All right, what's the first thing we need to do? Switch the mode. All right, we are in the wrong mode, so we'd go to mode, switch it to degree mode. I can't do secant, so instead I'm going to do its reciprocal. I'm going to do cosine of 120. Press enter, and then hit your reciprocal button. Press enter, and I'm hoping you're looking at a -2. Okay, last one. Go ahead and do it. Cotangent of 180. We're already in degree mode, so that was good. Can't do cotangent, so I'm going to do tangent of 180. Press enter. Now I'm doing the reciprocal, so hit your reciprocal button, press enter, final answer. Oh, wait a minute. Did you get an error? Yes, you did, because when you did tangent, you got a 0, and the reciprocal of 0 is undefined because it pops your 0 that's in the numerator, it pops it to your denominator, and that's undefined. So if you get an error, don't freak out. It's just an undefined situation. All right, so another thing we can do with right triangle trigonometry is just solve missing sides or angles in a right triangle. You always have to be given two things. That might be an angle and a side or two sides. You have to be given two things. So in this case right here, they've given me, actually I say two things, and you have to know that it's a right triangle. I guess that's important also. All right, so they've given me this angle 50 degrees. And they've given me the hypotenuse, and I'm looking for the adjacent. So when I look up here, I'm looking at cosine because it's the one that deals with hypotenuse and adjacent. So I'm going to do cosine of a 50-degree angle, and that is supposed to equal the adjacent, which is x, over 7, your hypotenuse. All right, so if you have this going in your calculator, we should already be in degree mode because those last problems were in degrees. And then we're going to go ahead and just take the cosine of 50. And what you need to do is take it times 7. But you be careful when you hit your cosine 50, you have to close that parenthesis, then do times 7. And I'm getting x to be 4.5, I'm going to say. Now, I always like to do a quick glance and make sure that it makes sense. I mean, there are some things you know about a right triangle. You know that the hypotenuse has to be the longest. So when I search for a leg, I'm happy to see that it is less than 7, but not weirdly less. Because what can happen is if you are in the wrong mode, you're going to start getting some weird numbers probably. So if you do, don't just write it down and keep moving. Maybe check your mode. All right. All three of these are different. I've set them all up purposefully in a different way. In this next problem, it's a right triangle. They've given me this 37, and they've given me the opposite. I'm looking for hypotenuse. Up here, opposite and hypotenuse are right here. So I'm going to be doing sine. So I write sine of 37 is equal to opposite over hypotenuse. Now you can see in this scenario that instead of having a number in my denominator where I can just multiply it over, I have a variable. So I actually have to multiply both sides times x. So I'm going to have x times the sine of 37 equals 12.3. So I'm going to end up actually dividing here. Sine of 37 on both sides. So in my calculator, I'm just going to type 12.3 divide sine 37. Enter. All right, so I've got an x value of 20.4. And looking at what I'm dealing with, that is my hypotenuse. I have this leg that's 12, so I think a 20 is going to be okay. All right, last problem here. Notice what's given this time. 2 legs. I'm actually searching for the angle. So I need this angle. They've given me opposite. They've given me adjacent. Opposite and adjacent are tangent. So I'm going to do a tangent problem, but this is a little bit different because I don't know what I'm taking the tangent of. Just the tangent of theta would equal opposite of theta is 15, adjacent to theta is 11. So what I need to do to solve for theta is I need to get rid of tangent. I need to get that apart from the theta. This isn't really being multiplied. It's not that. I just have to do the opposite operation. And that's called inverse tangent. And on your calculator, that's that tangent with a little -1, which is the second tangent. So all you really have to do is, and this is, I'm going to do this one time and I probably won't ever do it again. You'll just know I'm going to do the inverse tangent on both sides. When you take a tangent and an inverse tangent, they cancel, and I get theta equals, and then I'm going to do inverse tangent of 15 over 11. So second tangent, 15 divided by 11. And I've got theta to equal 53.7. Now remember, that's an angle measurement, so that seems kind of reasonable for an angle in a triangle. All right, hopefully you kind of remember that from previous classes. Really what we want to do is not just work with generic triangles, but actually be able to solve problems with this. And so one of the common things we see is an angle of elevation and an angle of depression kind of situation. Now, you always go, when you're just doing angle of looking up or looking down, that's called angle of elevation or depression. And you always will go from your line of sight. So if you're looking up at something in the sky, that's your angle of elevation here. If you're looking down at something, this is your angle. From your line of sight down to that ray that shows what you're looking at. Now that angle of depression is a little bit trickier because if you look at the triangle that's created here, it's this triangle right here is your right triangle. And that angle of depression right here is not really even in the triangle. So, but we can get to it because if you knew this, like these two are going to add up to 90 because you create a right angle. So if I knew that this was 20, then I would know this is 70. I could just subtract from 90 to get it. Now, in previous classes, they probably gave you a picture. I'm going to make you draw your picture. So I'm going to give you a moment. If you would read through this. Okay. Let's draw this picture. You have some sort of cell tower here. And then I have a guy that's going to be standing over here on the side that is 70 yards away. Now he is measuring up to the top of this cell tower right here, and he is looking upward. So from his line of sight up is 73 degrees. Now, I'm going to go ahead and say, don't get too caught up on the fact that this is on the ground here. And then I sort of angled that. I was cheating a little bit and made it look like it was Eddie's eyes. Don't get too caught up on that because there is kind of a difference based on his height and where he's looking from his eyes that would actually affect that height. But we typically don't worry about it unless it says something about that up here. And it didn't. Okie doke. So we've got this 73 degrees. We've got this distance is a 70. Now that 70 is adjacent to the 73. And he is trying to install a guy wire, some sort of a support cable here, right there, to support this tower. So that's what I'm looking for, is how long is that cable going to have to be? All right, so now let's look at what we have. If we have this 73-degree angle and we have the adjacent, and this is your hypotenuse, because your right angle is down here, adjacent and hypotenuse is cosine. So you set it up. Cosine of 73 is going to equal adjacent over hypotenuse. Take both sides times x. You don't really have to show this. Once you've done it enough times, you're going to probably not want to be showing that. So I'm going to type in my calculator 70 divided by the cosine of 73. Let me clarify what I just said there. I do want to see this step right here. I'm saying like this step. Maybe after you do it enough times, you know I'm going to multiply, come back and divide. So, but I do want to see how you set it up here. All right, my answer on this, x is equal to 239. And I'm going to go 0.4. Now that seems substantially longer than this 70, but I do notice that this is a 73-degree angle, and that means this up here would be like a 17-degree angle. And if you'll recall, I mean, a 17-degree, that's going to make this side a lot smaller than even that side. And this is the hypotenuse, and it's even longer. So I'm okay with my 239. In fact, I'm not even done, because we need to install 3 of these wires. So what do I need to do with this 239? Yeah, I'm going to take it times 3. So once I take it times 3, it looks like I need 718.3. And what were we in? Yards of cabling to order. And of course, I'll probably order a little bit more, but in general, that's going to give him a good idea of how much he needs to order. All right, here's our last one. I'll give you a moment here to read the question, and let's get that picture drawn. Okay, let me draw this with you. So here's the river. Here's the guy standing down here. And he sees that river in front of him. But then there's a bunch of mud in here. This is all muddy. Don't want to walk through the mud. So instead, he walks 400 yards along a 30-degree angle to the river's edge. And we want to know how far away the river was initially. So this is going to be what I'm looking for. This is going to be my x. Where do you, and then this would be your right angle. Where do you think that 30 degrees needs to go? Okay, the trick here is that is a 30-degree angle to the river's edge. That makes this the 30 right here. And he walked 400 yards right here. All right, so here's my x over here, hidden in the mud. Okay, there's my x. If I know this is a 30, looks like I know, or I'm looking for the opposite, and I want the I have the hypotenuse. I'm looking for opposite. That would be sine. Sine of 30 is equal to opposite over hypotenuse. This is the nice version. I can just multiply both sides by 400. So I'm in my calculator. I actually will typically hit the 400 first before I hit that sine. That way I don't have to mess with closing my parenthesis. And I can just do 400 sine 30, enter. And I got 200. That sure came out nice, didn't it? Did you happen to notice that that was a 30 and a 90? This is a 30, 60, 90 triangle here. Remember that in a 30, 60, 90, that your short leg is half of your hypotenuse. So really, we could have bypassed this altogether if you remember your special right triangles. Okay, so that's all I've got on this one. Go give your homework a try.